Ladies and gentlemen, Mr. Charles Reid.
Welcome, everybody. My name is Dr. Charles Reid. I'm a scientist at Lawrence Livermore National Laboratory, and I'm going to be talking today about science fiction and its role in science. So we're all here today to talk about Philip K. Dick, the Bay Area's own visionary science fiction author. And we're going to hear a lot today about the themes in his work, the central ideas behind his fiction, and we're going to hear about work inspired by Philip Dick. But the question that I want to ask is, why? What's the importance? Is this just so much intellectual flexing in front of a mirror? In fact, I want to make the question bigger. I want to ask, is science fiction important to science? Who cares about science fiction? Well, the answer is yes, it does matter. And there's two reasons why. Two reasons that I want to address today. The first has to do with technology. Science fiction helps us to look at our technologies and see the potential, see where it's going, the potential consequences. And the other is philosophy. Science fiction gives us this pool of philosophical concepts on which scientists can draw while they're solving science problems and doing science. So, as I mentioned, technology helps us explore consequences, and science fiction gives us this pool of concepts. It was the fall of 2001. I was on a car trip with my family through the Arizona desert. And I was reading an anthology of military science fiction. Some of you may have read this. And I was reading a story by Philip K. Dick called Second Variety. It was my first Philip K. Dick story. And I was completely engrossed by it. Now, in this story, there's a twist ending. It's a very dark, bleak, post-apocalyptic world where these robots that murder people are evolving on their own to look like humans. And the story ends with a human being giving away the key to the last bastion of civilization in this post-apocalyptic world to a robot. And I remember looking out the window at this dark, barren landscape and thinking that this had never happened before. I was contemplating this dark future in a world filled with war in which people's technology ended up destroying themselves. 3 days later, it was September 11th. And this dark, bleak vision that I had read in the story became a reality. September 11th ushered in this new era of technology being used for malevolent purposes. Governments using technology to surveil citizens, to restrict rights to information, rights to privacy. The military using technology like autonomous drones to kill people. And all of this was happening in the midst of a global conflict. Now, I'm a chemical engineer at the Lawrence Livermore National Lab. And as an engineer, I use science, technology, mathematics, and physics to create new technologies. But being an engineer requires you to answer certain questions about the technologies you're creating and the uses to which that technology will be put. You have to answer these ethical questions whether you want to or not. So if you don't answer them consciously, you're answering them implicitly. And if you answer those questions the wrong way, your technology can end up becoming malevolent. The way that technology works is well described by a poem by Johann von Goethe called The Sorcerer's Apprentice, in which a lazy sorcerer's apprentice uses magic he doesn't fully control to get a broom to fill up his bath for him. But he soon realizes that he doesn't control this magic. The broom is filling the bathtub and begins to overflow. So he tries to stop it, but he can't. Oh, you ugly child of Hades! The entire house will drown! Everywhere I look, I see water, water all around. So he takes the axe and he chops the broom in half. But now he's got 2 brooms, and more brooms, and more water. And everything is completely out of control. Until the sorcerer comes along, saves the day, and says, "Back now, broom, into the closet. Be as thou wert before, until I, the real master, call thee forth to serve once more." Sound familiar? Now, the engineer, that's this helpless sorcerer's apprentice, meddling with things he doesn't fully control. Except there's no magician to come in and save the day when things go out of control. So to return to this story, second variety, maybe it's a little far-fetched, this idea of autonomous robots evolving to kill people. I mean, that's ridiculous, right? That doesn't apply to our world. That's just somewhere in the future. Oh, hey, where did that come from? So how do we keep technology from becoming this malevolent force? We do it by consciously answering these ethical questions that come up when we design technologies. We do it by designing new clean energy systems instead of new weapons systems. So science fiction is giving us an opportunity to think about the consequences of technologies that we're designing, that scientists and engineers are designing, in order to think about where those technologies are going to lead and what uses they're going to be put to. And Philip K. Dick's fiction in particular gives us an opportunity to consider some of the darker consequences. So I want to return to this question. I've covered the answer of technology. Science fiction helps us look into the future to see the consequences of our technologies. Now, science is a deeply philosophical activity. Scientists of old were often called natural philosophers. And in fact, there's a long tradition of philosophy in science. Science deals with concepts like a priori and a posteriori in the form of mathematics versus empirical data. It addresses questions like, what's reality? What's truth? And are they the same thing? Is there a world beyond appearances, what Kant called the world in itself? Or is everything purely what we measure and what we observe? There are questions about knowledge and epistemology, like what kind of knowledge is descriptive and what kind of knowledge is explanatory? And is that a sliding scale? Or is it a binary? There's deeply philosophical concepts like uncertainty and error that show up all over the place in science. Now, I earned my doctorate in chemical engineering studying computational models for combustion, which is basically how fuels burn, gaseous fuels, solid fuels. And this is a really, really complicated topic. It's very poorly understood. There's a lot of uncertainty. There's lack of data, imprecise instruments. We don't really know what's going on. And so we have to rely on computational models to better understand reality. And there are all kinds of ideas about how these computational models work, and a lot of them contradict one another. The scary thing is, the deeper you go, the more you start to realize there is no right answer. There is no truth. One day I was sitting in a meeting for my research group, a research group meeting, and two professors were arguing about the finer points of how to compare simulations to data. One professor was saying, "My simulations are so high fidelity, with so much numerical accuracy, and so much physics, that we can trust them and use them as surrogate experimental data, because we can't gather data in this regime." The other professor said, "No, data is data, and simulations are simulations, and we need to keep them separate." And suddenly I found myself full of opinions, and I jumped in almost without realizing it, arguing for the latter point, that simulations are not real. Where did this come from? All of these opinions. They came from Philip K. Dick. I'd been reading Philip Dick's fiction and short stories throughout my high school, college, and graduate school careers. And I'd been filled with concepts like reality, truth, knowledge, certainty, and uncertainty. And these all began to show up in science. So reading Philip K. Dick's fiction gave me this pool of concepts on which I could draw in order to put science and philosophy of science problems into terms that I could understand. That conversation in the conference room went on to have a profound impact on me. My dissertation was creating a mathematical framework in which we could translate computer simulations into synthetic knowledge and quantify the level of belief in that knowledge. And this was a deeply philosophical activity and required a lot of grappling with terms like reality, truth, error, uncertainty. So let me return to this question once again. I've covered the second point, which is that science fiction gives us this pool of philosophical concepts on which we can draw. And Philip K. Dick's fiction in particular is very strong in these themes. His simulations are androids and alternate realities and drug-induced alternate realities. But the idea is we're still thinking about simulations. We're still thinking about what's real and what's true and what's observed and the relationship between all these concepts. So my hope is twofold. First, I hope that by addressing these philosophical questions consciously, we can eradicate this default trust in technology. This idea that when we create a technology, we can automatically assume it's benevolent until proven otherwise. We see this a lot. If you talk to any coder, he'll say, "Oh, my code doesn't have any bugs in it." If you look in the news at Facebook and Google, do a news search with the word privacy in there, you'll see all kinds of examples of this. The companies assuming that technologies are benevolent and people getting upset because they're not. The other thing I hope is that thinking about the consequences of the technologies that scientists and engineers are designing will help us to create technologies that are benevolent, to address important questions like clean energy, clean water, global warming, instead of designing more weapons for more destruction. Because we need all the benevolent technologies that we can get in this malevolent world. Thank you.
Are you using purely statistical analysis, so like a Bayesian approach, or are you actually looking also at the sort of social authority structures that help inform whether or not things are believed? Is it purely on the...
It's purely mathematical. So the question was, can I explain more about my dissertation and how I'm quantifying belief in knowledge? It's purely mathematical. What I'm doing is I'm taking large-scale supercomputer models and reducing those, and then exploring the parameter space statistically to say, here's statistically speaking, here's what we know comparing to data we have, and then extrapolating that to realms where we don't have data and saying, here's our statistical confidence level. So we might say, we want to run a simulation of combustion under these conditions, this pressure, this temperature, this fuel mixture. We don't have any experimental data, but using this model, which we know is right in these regimes, we can predict that it'll be right with 90% certainty, or 75% certainty, or 10% certainty. Yes?
I'm an attorney. There is required ethical training for attorneys. It happened after Watergate. People saw all the attorneys involved in Watergate and said, gee, we'll train attorneys in ethics and this will never happen again. What it turned into is attorneys being attorneys, attorneys found ways to rationalize anything they did. Now, in World War II, there were scientists on both sides working on nuclear weapons. And I think, I wasn't alive then, but I think it would have been very foreseeable to anyone who had enough intelligence to work on a nuclear weapon what the consequences would be of letting the genie out of the bag. Do you think there should be required ethical training for scientists?
Absolutely. And so the question is, should there be mandatory ethical training for scientists? And I think the answer is yes. And I also think the answer is we're seeing more of that, but it's not pervasive. And I think in the world that we're in today, where technology is everywhere, not just the internet, but we're starting to see technologies like 3D printing, the Internet of Things. We're seeing things go from this kind of contained cyberspace world and start coming into the real world and manifest themselves in the physical world. I think this is getting really, really important. And we're seeing a lot of confusion about where we draw the line. So I think ethical training for engineers and scientists creating these technologies is really important. Whether or not it's specific to particular technologies is, I think, irrelevant. It would serve the same purpose as reading Philip K. Dick. You start thinking about some of the darker consequences of the technologies you're designing.
Well, it's typical in one sense, in that his scientific explanation of an alternate reality, a drug-induced or drug-influenced alternate reality. I'm wondering how you look at that aspect of Dick's work. It obviously pervades other novels too.
So the question is, how does the aspects of Dick's work that are sort of meta-science, I guess?
Subjective reality.
Subjective reality, okay. How do I see those? I think, for me, science fiction isn't something where I'm looking for a purely scientifically correct explanation of things. I think there's a willing suspension of disbelief when you read science fiction. And I tend to do that with all the science fiction I read, with the exception being more hard science fiction. So I see it as, what I'm getting out of it is more of the philosophical concepts underlying it, which I can then transfer to the science that I'm doing. Does that answer your question?
Well, no, but I think, I'm not a scientist, I'm a writer. That's just fascinating and wonderful, but I wonder to a scientist whether that's, entertaining and amusing, but ridiculous on some level.
Not at all. And I think the further down you go, the more you realize that this whole idea of quantum physics, it sounds like a kind of fuzzy idea of the Heisenberg uncertainty principle. Oh, that's just a fuzzy way of describing uncertainty. But really, it does apply. If we think about temperature, there's no such thing as temperature. It's just an arbitrary definition of the average kinetic energy of a bunch of molecules. And the average kinetic energy of a bunch of molecules depends on its velocity. And the velocity can't be measured because of the Heisenberg uncertainty principle. So we never quite know how fast a molecule is going. So we can never quite know what the temperature really is. So we never quite know what the truth is. There is no truth. And this is very true in science.
Somewhat true.
So how can you treat ethics then? I mean, how can you teach ethics if especially with this that you just said? I mean, whose ethics? And, any good novel, especially Phil K. Dick, doesn't have complete ethics.
I'm going to let the lawyers take that question. I think that's more of a, so the question was, if you take this subjective view of the world, how do you teach ethics? And I think that's far above my pay grade. I don't mean to dodge the question, but I'm going to. Yes, I think ethics is important. And the reason is it makes us ask questions. I'm not saying that there's a right answer or a wrong answer, but I think there's an importance to asking the questions in the first place.
Are you seeing technology as something that's automatically exterior to the human, or would you say that humans are almost intrinsically technologized? Because I think, for me, that's one of the things Dick deals with, is the mistakes societies make when they attempt to compensate for certain forms of human technology. It's already in the human, and they just reproduce it by replacing one with another. A supercomputer replaces the UN, and then they don't realize that the supercomputer is also going to go off in another tangent and develop another form of technologizing behavior.
So the question was, do I think technology is an internal process or purely an external process? I think it's very much about the internal process, the search for more, the search for knowledge, and I think that's what science is all about. It's about that something inside of us. And you see this in Dick's novels, when we get to a point where it's a post-apocalyptic world and we've lost all knowledge, people are still looking for the answer, however they can find it. So I think technology is kind of a glass of water satisfying a thirst. And if all we've got is a glass of beer, we'll drink that too.
I wonder if you could go a little more into the rationale behind your strong opinion that it was different. The simulation versus the experimental data itself.
Okay. So you want me to expand on why I think that data is data, simulations are simulations, and there should be a distinct division between the two. I think this gets to the philosophy of science that I adopted, which is instrumentalism. And this was a view advocated by Ernst Mach. He saw the world as not existing in itself, but existing purely as phenomena. It's also, instrumentalism is kind of another version of phenomenalism, where there is no world in itself. The only thing we know about the world are the phenomena that we receive. So we can't really know whether or not there's something outside of us. So taking this perspective requires you to treat phenomena very carefully as the only information that you have about reality. So if you throw that away, you're throwing away the only thing that you have about reality. And if you throw it away in favor of mathematics and logic, well, mathematics and logic don't govern the universe. We can't peel back the face of the world and see a framework of mathematics underneath it. And I think this is manifest by the works of people like Russell and Whitehead in their Principia Mathematica, trying to show that mathematics really could be built up from the most basic logical principles into the whole universe that mathematics has become, and failing. And Kurt Gödel coming along and publishing his proof formal inconsistency of systems, showing that you can't have a system that's entirely self-contained and entirely self-consistent. It's one or the other. If you want to show that your system is consistent, you have to step outside of it. So there's this internal, innate contradiction in mathematics that makes it ultimately this impossible attempt. So there's really no mathematical structure to the universe. It's really a language that we're using to describe what we see. We count numbers. Well, numbers are base 10. That's not arbitrary. It's based on this. If we had this, we'd be counting in base 8. So I think the deeper you go in mathematics or science or physics, the more you realize that the universe begins to fray at the edges. And this image that we're taught of there being natural laws, that Newton has these laws, or that there's the laws of thermodynamics, these are just rules that generally tend to work most of the time. And I think when we get into deeper and deeper scales, we start to see those things break down, and we see the interfaces between things break down, and we see our knowledge break down. And so I think that's what science is really doing now, is trying to push deeper and deeper, smaller and smaller and bigger, and trying to figure out, how do we stitch all these things together? And really, can we stitch all these things together?
I've thought for a long time that one of the things that Dick is doing is kind of dramatizing these ethical problems and epistemological problems in the philosophy of science. But I haven't read much about it, so my question is two parts. First of all, is there much that's been written along the lines of what you're talking about? And second, what advice would you have if somebody wants to do like a reading of ethical problems in the novels of Philip K. Dick?
So the question was, has there been much writing on these questions, and what would I recommend for a reading? So first, to answer your first question, absolutely, there's been a lot of work on the philosophy of science. And a lot of it's started from...
No, I'm sorry, I mean specifically in Philip K. Dick, like scholarship on Dick that reads him as a writer about these problems.
I see. I haven't explored the Philip K. Dick scholarship very deeply, but I haven't read anything particularly. With regards to the reading, I thought a lot about this before my talk, and I think that it's not so much particular books or stories that are blatantly talking about these issues. I think it's really everywhere. I got started by reading the short stories of Philip Dick. And I think the short stories are a great way to get exposure to a whole lot of ideas and a whole lot of contexts and situations, and seeing these problems addressed in all kinds of different ways and getting exposed to them multiple times in multiple stories. And that was really my primary exposure, was reading the short stories. And then I got more into the novels. But I think the short stories ultimately were what really turned me on to those themes in Philip Dick.